there are two different methods of EMF induction. So methods of EMF induction. So I'll just make it clear now. Methods of EMF induction. So what is that? Methods of EMF induction. That's okay. Now we'll see what is the first method. The first method that we'll be seeing is, let us indicate that with A. It's called dynamically induced EMF. Dynamically induced EMF. Okay, and the second one that you find is statically induced EMF. Okay, that's good. What is about dynamically induced EMF? In the name itself, we have a point to say that dynamically induced EMF, which means in the process of EMF induction, we need to make some, or we need to create some dynamics. What dynamics? Wave dynamics. So let me give you some hint here. You know, the first law of Faraday is the basis for the first method of EMF induction. Hope you are understanding me. The first law of Faraday is a basis for understanding or for realizing or deriving the first method. So what is that? First law of Faraday. Okay, what is the first law of Faraday? Whenever a conductor cuts the magnetic flux, EMF is induced in the conductor. This is what is the first law of Faraday. So let me take the magnet in the picture now. Okay, this is my magnet. This is North Pole and this is South Pole. Obviously, you will find the flux lines moving from north to south. Now, what I do, a blue line, I take a conductor. Okay, so what is this conductor now? Now, what I have to do? I have taken a magnet, I have taken the conductor. So what is Faraday's first law is saying? Whenever a conductor cuts the flux. Okay, now I just move it towards and away, something like this. Then it is cutting the flux. Okay, that's how it is inducing, it is satisfying the first law of Faraday, and thereby I can say that because it is cutting the flux according to the Faraday's first law, we can say that there can be a EMF induced, and if it is closed with the load, then you will have a current flow through this conductor. So what is there, my dear? There are two elements which are used. One is the magnet, the other is the conductor, and third one is dynamics between them. Okay, hope you are understanding or you're following me. Now the second way, this is the first way of executing Faraday's first law. Okay, now the second way of executing the same, very simple. I take the conductor, but I don't move the conductor, but still I need to provide, I take the conductor and I take the magnet as it is, like the previous discussion. Okay, and now I don't move the conductor, rather I move the magnet. I will not move this. I move this magnet, towards and away from the conductor. So what am I doing here? In the opposite way. So here the conductor was in movement. Are you understanding me? Now here the magnet is in movement. Now can you now figure it out which machines, which generators are having conductors in movement, and which machines or generators are having field in movement? Very simple. So here actually we are moving it up and down, but in the real-time generator we have to take the movement in a rotating fashion. That's how we have our generators dynamically rotating all the times. So rotation. So here we are moving it up and down linearly, but in that you have to move it circular, I mean to say in a angular direction. Okay, now which machines are having the conductor in movement? In other way, we can say that all the machines have stator and rotor, right? So which type of machine has the conductor on the rotor? Simple, the conductor rotating, Is that okay? So in which machine we have the conductor rotating? In which machine we have the field rotating? Can you just think of it? If you clearly think, you will understand a fact that all the DC generators have got all the DC generators are being realized with this method of dynamically induced EMF. Dynamically induced EMF is a method which is based on the first law of Faraday and which is realized in a DC generator, right? And in DC generators specifically, if you can see, you will find the conductor on the rotor moving, armature conductors are moving. Armature conductors are moving. Now let us go to the next way of realizing. So what you have done here, you moved the magnetic field than the conductor. So in which machine this way of EMF induction is realized or is seen in the real time? You would find in all the generators which are AC generators, in AC generators, basically you find the field on the rotor in the movement, and the conductors spread on the conductors are distributed in the windings on the stator. So what was it? The conductor was in static. Is static. The conductors are static on the stator, but the field is rotating, dynamic on the rotor. Do you understand now? Dynamically induced EMF can be, this method can be implemented in two ways. One is by varying the field, the other is by varying the field, the other is by varying the conductor. Varying the conductor or moving the conductor or rotating the conductor, dynamics made by the conductor is seen in the generator, and dynamics made by the field in movement. Okay, field on the rotor is seen in all AC generators. That's fine. Now, what about the second method, statically induced method? Statically induced EMF. Statically induced EMF, the name itself is saying that it doesn't move. It doesn't have any dynamics. There is no rotor portion seen in this method. There is no dynamics, which means where we use it or how it is going to be, understood. Let's see this now. So you take a coil, and to realize that, to understand this, you need to take a coil and give a AC supply to the coil. Then what happens, my dear? V of t, and then the current flows as I of t, So when you are providing a alternating voltage, then definitely alternating flux flows. Okay. Now the alternating flux will produce alternating current produces alternating flux. So what is this one? What is this method? Statically induced method. To understand that, you took this setup, and let me tell you on which basis this method can be understood. As this method is on the basis of first law, this method is on the basis of second law of Faraday. Second law of Faraday. What is second law of Faraday is saying? Second law of Faraday is not saying anything about magnet. Is not saying anything about dynamics or cutting the flux. It's just said like this. Second law of Faraday is saying that the rate of change of flux or conductor is directly proportional to the EMF. What is that? The rate of change of flux linked with the conductor is proportional to the EMF. Okay, so now what I have taken a coil and I have given some AC supply current, voltage, and then it is giving AC current to me, which is producing the flux, AC flux alternating, and this flux, which is AC, is changing with respect to time, which means the Faraday's second law is now being satisfied. Rate of change of flux is seen in the winding. Yes or not? There is some flux linked with the winding, and this flux is changing in nature, changing in nature by its virtue. Why? Because it is AC supply. Let us, for an example, For an example, or if you assume that you are giving a battery supply instead of AC supply, you are giving a DC supply, okay, then what happens? There will be a DC current. DC current will produce DC flux. What is DC flux? It doesn't change with respect to time. When it doesn't change with respect to time, Faraday's first law will not be proved. Okay, if the Faraday's first law is to be satisfied, there should be a flux linked with the conductor or coil which is continuously varying with respect to time. So what I take now, rate of change of flux is proportional to the EMF. So only in the case of AC supply, it gives a AC current, and thereby it gives the AC flux, which is nothing but having the flux value changing continuously with respect to time, and that change is proportional to that change of flux is proportional to the EMF. Okay, suppose, as I said, if you take a DC supply, nothing happens. You know why? There will be a current, there will be a flux, there will be a flux. This will act as a magnet. There is no doubt in that. You know, this is acting as when it produces the flux, the coil is acting as like a magnet. It's a virtual artificial magnet. But that flux which is linked with that, coil, a DC flux which is linking with the coil, doesn't change with respect to time, which means it cannot produce EMF. Only the flux which is changing with respect to time can produce EMF. Okay, so this is how it is to be understood. Now, if you resolve that, as I said in the beginning, it is minus N into d phi by dt. Okay, now minus is indicating, N is the number of turns that you find in the coil, and minus is the sign because the EMF induced here, the EMF induced here in the coil, here in the coil is opposite to the supply that is applied to the circuit. So it is opposing. I hope it's not. Yes. So what is that? Yeah, EMF induced is always opposing the reason for its production. This minus sign is indicated because of the lens effect. What is lens effect? Lens effect is said very clearly that the effect opposes the very cause of its production. What is that? Effect opposes the very cause of its production. So what is the effect here? EMF induction is the effect. And very cause of its production is what? Rate of change of flux. Okay, so the one reason or one way you can say that it opposes the main voltage. The other way is that you can say is like it is opposing the very cause of its production. What is opposing? EMF induced in the coil is opposing the very cause of its production. Okay, so that is how Lenz's law is defined as effect opposing the cause. What is that? Effect opposing the cause. So effect is EMF induction, cause is rate of change of flux. So EMF is opposing the rate of change of flux. This is how we can understand about both the methods. So I'll just summarize these two methods. First method is dynamically induced EMF, which is based on the first law of Faraday, and second method is fundamentally based on second method, statically induced EMF method, is fundamentally based on the second law of Faraday. So in first method is being used in all the rotating machines, whether it is DC machine or AC machine. As I said, DC machine we have the conductor in movement. In AC machine you find the field in movement on the rotor. Okay, and the second method is a method in which there is no dynamics seen, and it is simply is just taking a coil and giving a supply. So it is in one way voltage is the input and voltage is the output, and this voltage whatever is produced is opposing its very cause of its very cause. So E is opposing d phi by dt. So it is shown in the reverse direction, and this method of EMF induction is seen in all the static machines. Static machines are like all the transformers, auto transformers, all the stuff where you have where there is no dynamics, something like transformers. Generally we use in transformers, okay, primary winding, secondary winding, all that stuff will mean primary and secondary EMF inductions are also based on statically induced EMF method. Hope this is useful to you. If you like this particular lecture, please subscribe. Thank you.